Hello, 7th grade. Before we get started, there's something that I do want to talk to you about. I know that you can't say anything back. This is going to be for some of you, not the majority of you. But I want to talk to you about Friday's homework. And it was not good. It wasn't good in the terms of some of you did not post your work. And some of you, when you were dividing fractions to a percent, I knew that you were using a calculator because some of the answers that I was getting was only what a calculator would give. In order for you to get credit for your work, you must do your work on another sheet of paper and turn it in. Or else I'm not going to give you credit for it. I don't want to know what a calculator can do. I'm sure it's going to give you the right answer. Now, I don't mind if you check your answer with a calculator, that's fine, but I still have to see your work. I want to know you're doing the work because all this stuff is not new. This is all review. All right, so you should be able to do it just fine, especially the arithmetic, without a calculator. Some of the questions I could tell that you didn't even try. Some of the answer choices were just chosen, and there was nowhere I could tell because some of the answers were left field. All right, so it's not that hard. And again, if you are struggling on a question, I'll be more than happy to answer it. You just have to leave me a comment. But let's not start going downward with our work. Some of you are okay. Some of you are doing what I'm asking. Some of you are not. And those are the ones that really need to pick up the slack. All right, so let's go ahead and continue with the homework from yesterday. Elijah estimates that 80% of the email he receives could be classified as junk. To predict how many junk mail messages he might receive out of the next 50 emails, he places 8 red and 2 blue marbles in a bag. He draws 1 marble at random from the bag and records its color before replacing it. He records the following results. Now, it's important to know that the 80% is the junk, and if I have 8 over 2, or 8 red, 2 blue, well, that would be a total of 10. So the red would represent the junk, because 8 over 10 is 8/10, which is 80%. All right, so how can Elijah use the results of his simulation to predict the number of junk mail messages he will receive the next 50 emails? So typically what we do here is we just set up a proportion. So let's go ahead and do that. So let's count how many red there are. And right now I'm just circling all the reds that I see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 15 out of 20. All right, those are red. Now, if he is getting 50 emails, well, 50 would go on the bottom because that's the total. All right, so typically to solve this proportion, we're going to multiply 15 times 50, and then we're going to divide by 20. But what you could also do, and it's going to give you the same answer, is you can take this, you can divide this out, and multiply it by 50. So what we're doing is and that's just because you multiply by 50, you divide by 20. That's what the proportion tells us to do. Well, there's only one answer choice that says that we're going to count up the number of red, divide or multiply by 50 and divide by 20, and that's answer choice C. It's not D because we don't want to count up the blue. Blue is not junk. Blue is his emails that he needs to receive. So the answer there is C. Number 24. Dina strikes out 25% of the batters that she faces when playing softball. To predict how many batters she will strike out of the next 40, she tosses a number cube labeled 1 through 6 twice, and then records the number of times both results are odd, so that's a yes, and not odd, and that's a no. Based on her results, what is the experimental probability that Dina strikes out a batter? So the yes are the strikes out a batter. So we have to count how many yeses there are. So let's circle the yeses. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 out of 40. And I want to simplify this by 4. 12 divided by 4 is 3. 40 divided by 4 is 10. So the answer is F, 3/10. And hopefully you have your work in front of you. And if you've missed it, you are going over it. Next, number 3 on your paper. Dan spins a spinner with 4 sections numbered 1 through 4 and records the outcome. The results of 20 spins are shown below. What is the experimental probability that he spins a 1? So now I have to look at how many times that he has spun a 1. Count those up. 1, 2, 3, 4, 5, 6. So 6 over n. I don't even have to add how many times he did it. It tells me 20. All right, let's simplify that. And let's see here. Sorry, dividing it by 2, I get 3/10. So again, the answer is 3/10. The answer choice is D. Next page. A company plans to wrap cheese in the shape of a triangular prism like the one shown below. What is the least amount of wrapping paper required to cover the cheese? So right here, this is surface area, right? Because if we're wrapping, to wrap is area. And also, look at your numbers here. That's squared inches, so that's area. So this is surface area. So I need to find the area of all the sides. So a triangular prism has this triangle here, and this triangle here, so that's 2 sides. So if I find the area of one triangle, I have the area of the second triangle. Then we need to find the rectangle area. So there's 1. Here would be another rectangle, and there would be another one back here. So I have to find basically 5 faces. So the first thing I'm going to do is let's start with the triangle. So that one's easy. So A equals 1/2 BH. And I know it's base times height because there's my right angle right here. So I'm going to use 3 times 4. So A equals 1/2, 3 times 4. And again, it's multiplication, so I can multiply in any order. 1/2 times 4 is 2. 2 times 3 is 6. So this one is 6. So if that triangle is 6, the other triangle is 6. So I'm just going to I'm going to write that down twice. But that's 12. If you want to write 12 for just that one, you can. Now let's work one rectangle at a time. So let's work this bottom one that it sits on. Well, the dimensions are 8 times 3. And then that's length times width, right? So 8 times 3, that's 24. So I'm going to write 24. The next face, or the next rectangle I want to work with, is this one right here. The one that I outlined it in red. And those dimensions are 8 times 5. So I'm going to use the same formula. I'm just going to write 8 times 5, and that is 40. And I have one more rectangle, the back one. Let me erase this. And this back one, I'm just going to outline it in red as well. Well, I know that the dimensions are 4, because that's what I'm doing right here, using this one. And if this is 8 out here, this has to be 8 back here, because they're equivalent. So I would use 4 times 8, which is 32. And just to add those up, 6 times 6 is 12, plus 4 is 16, plus 2 is 18, carry. 1 plus 2 is 3, plus 4, 7 plus 3 is 10. So this would be 108. Next. Which method would allow you to estimate the value of pi? So again, one of the ratios that you have to know, pi equals C over D. So the ratio of the circumference over the diameter. And the one that shows that is B. Find the ratio of the circumference to the diameter of a circle. Okay, going down or moving up. A piece of string that is a foot long measures 30 and 48 centimeters. How many centimeters are in an inch? So hopefully you were able, or you still have your conversion sheet that I gave you that goes from metric to centimeters. Okay, so what I have is 1 inch is equal to about 2 5400 centimeters. And whenever we convert, when we're going from metric to customary or customary to metric, we need to put that in a proportion. So now let me write where the 30 and 48 hundredths would go. That's on the bottom because we want to put centimeters across from centimeters. Now if you have it on top, that's okay. So now we would do 30 and 48 hundredths times 1, which is 30 and 48 hundredths. And we're going to divide that by 2 and 54 hundredths. Move your decimal twice on the outside, twice on the inside. $254. Let's see here. Would go into 304. Okay, never mind with this. I was doing too much work. That's wrong. I really did already answer it. It's just asking how many centimeters are in an inch. So I don't even need that other information. Then you just get that from your chart. The answer is G, right? 1 inch equals 2.54 centimeters. All right, so yeah, I was doing too much. All right, moving on. Now, you know what? Let me go back to this problem right here. Okay, the reason I wanted to come back to here is because what if you did not have your math chart or the one that has all the conversions? And that very well might be the case. So one way to do this, since it tells us that it's a foot long and we are trying to go to an inch, well, I know that there are 12 inches in a foot. Now, here is where we get what we need to do. So it says centimeters are in an inch. What that really is telling us is that we need to find centimeters per inch because we're looking for 1 inch, right? Centimeters per 1 inch. And so this right here tells us the fraction that we have to set up. So it would be 30 and 48 hundredths centimeters over 12 inches. And then this we can divide. So without even knowing the conversion, you can just work it this way. So 12 into 30 goes in 2. 24, that's 6. 4, decimal 5. 64, 48, 4. And that divides out evenly. So that's another way to do it. So either you could have gotten the answer from your conversion chart that goes from metrics to customary, or you could have done it this way. So either way works. All right, moving on. On a map, the distance from San Antonio to Abilene is 6 25 hundredths inch. The actual distance is 250 miles. What is the scale of the map? All right, so a scale is really, it's just we're going to put it in a fraction of some sort. So here it tells us we're going from inches to miles. So inches over miles, 6 25 hundredths inch over 250 miles. And what we're going to do is I'm going to clear the decimal out in my numerator. So in order to do that, I'd have to move it 2 times to the right. Or that's multiplying by 100. Now I can multiply by 100 to my numerator, but if I do that, I have to multiply it to my denominator. So what I get is 625 over, oops, my stylus isn't working, 25,000. Now I can simplify. So what I'm going to do is, the first thing I'll just simplify by, I guess we'll work out 5 first. That would be okay, because they both end in 5 and 0. So let's do it by 5. And we're going to do both of them, right? So 625 divided by 5 is 125. And 25,000 divided by 5 is 5,000. 25 divided by 5 is 5, and then you just add the zeros, right? So again, we can divide this by, I guess we'll do it by 5. 125 divided by 5 is 5, and 5 divided by 5 is 1,000. All right, so next, 5. Divide this by 5. So that's 1 over, why did I get 200? Give me a second. Oh, that's what I did wrong. This is 25, not 5. Oops, oops, oops. Here we go. Sorry, it's too many mistakes. All right, now let's divide this by 5. 25 divided by 5 is 5. And 1,000 divided by 5 is 200. And let's divide this again by 5. 1 over 40. So that, as a ratio, is A. Next. (24). An isosceles triangle has exactly one 50-degree angle. What is the measure in degrees of one of the other two angles? So I'm going to go ahead and draw my isosceles triangle. So what do I know about an isosceles triangle? Well, I know two sides are exactly the same, and it gave me the side that was different. So if this is 50, and I don't know what either one of these is, but I only want one of those. Well, I know that a triangle is 180 degrees. So if I subtract 50, this 130 is for both of these put together. And if I want only one of those, I would divide that by 2. And I get 65. So the answer is 65. Now to the arithmetic. The arithmetic was pretty easy. It wasn't that hard. So I'm just going to use this middle one. 16.2 plus 3.8. That's 15. Carry 3. Carry, so 43 and 5/10. Next, 56. Oops, I wrote that wrong. Line up your decimals. 5.6 plus 11. All right, 10, carry 1, carry 4. So that's 41. Next, multiply. 9 times 6 is 54, carry the 4. 9 times 3 is 27, plus 5 is 32. 9 times 2 is 18, plus 2 is 20. All right, move over. A row of zeros, move over again. And then everything times 1 is just itself. So 4, 3, 6. Ooh, I did something wrong. All right, let me check my math. 54, 27, 32. I transposed these. But y'all are screaming at me. This is 3. This is 2. This is 1. Okay. 2, right? 752. Number of decimal places 3, so 25 and 724 thousandths. Next, the division. So let's move it over once, and I'm going to add my decimal there. Okay, 376 goes into 305 no times. That's a 0. All right, 376 goes into 3050, and that's about 8 times. And we get 3008. And so we get 42 when we subtract, and we can just stop there because I just want you to go out to the hundreds. All right, next, subtraction. 1, 13, so that's 8, 6 is 5, 11, 9, 7 and 98 hundredths, and the last subtraction. And we get 881,000. So again, remember, for tomorrow's homework, you are to still prove your answers on another sheet of paper. So you have to do both the form and the other sheet of paper. So make sure that you are uploading your questions on the form. It's probably best to work out the questions on another sheet of paper, and then once you have all your answers, just to go back and add them onto the form. Make sure that you do show your work for the arithmetic so you can get credit, because if there is no work, there is no credit. All right? Well, y'all have a good one.